Great. Well, thank you very much, Chris. And thank you all for being here. It's really a pleasure to be able to present the findings of the Working Group 2 report to you. You've already heard a little bit about the process from Chris, and I wanted to just say a few more things about that. The Working Group 2 contribution to the 5th assessment report is the culmination of nearly 5 years of work with over 300 authors evaluating more than 12,000 scientific publications and also responding to more than 50,000 review comments from expert and government reviewers from around the world over multiple rounds of review. And as you heard from Chris, the final step in this process is a few weeks ago in Yokohama, Japan, the authors met with representatives of the world's governments to approve the summary for policymakers, this short document that boils down the 2,000-page report into something that's about 25 pages and ensures that the key conclusions of the report are understandable outside of the scientific community. So the result of this really extensive multi-year process is a comprehensive stock-taking of what is known about climate change impacts, adaptation, and vulnerability. And what Katie and I are going to be doing in this presentation is taking you through the main messages of the report. As a starting point, Chris has already talked about this framing around risk in the report. And when you think about the impacts of climate change, it's really important to understand that the impacts result from risk that emerges from the interaction of 3 different factors. The first is climate-related hazards. These are physical climate events or trends in the climate system, represented as hazards here on the screen, that interact with vulnerability, which you can think of as who is susceptible to harm and why, and then exposure, who and what is in harm's way. And these three components interact to determine risk. What that means is that the same hazard can lead to very different impacts depending on differences in vulnerability and exposure. Over time, changes in both the climate system and in socioeconomic processes affect these risks by changing these 3 components. So one important aspect of that is that emissions of heat-trapping gases are driving climate change and are increasing climate-related hazards. Socioeconomic development can also increase or decrease vulnerability and exposure over time. So for example, development trends, such as more people living in coastal areas, can increase exposure to coastal hazards, and that's something we're seeing over time. In contrast, reducing vulnerability and exposure can also be affected through development choices, through policy choices that help us become better prepared for the impacts and the risks of climate change. And the final aspect that you see on this figure is that there are also feedbacks from the impacts of climate change to both the climate system and to socioeconomic processes. So, for example, some impacts of climate change, such as thawing of permafrost, can lead to more emissions of heat-trapping gases that further reinforce climate change, further exacerbate climate change. Also, you can have impacts of climate change that affect economic activities, economic growth, and that feeds back to socioeconomic systems. So both of these feedbacks also affect risks over time. We here at Stanford worked on the Working Group 2 report. The Working Group 1 report, which focuses on the physical science basis, what we understand of the physical climate system, was released in September of last year. And that report confirmed that, first of all, warming of the climate system is unequivocal. And this map shows you warming around the world since the beginning of the 20th century. It indicates that there's been a significant warming trend almost worldwide and in terms of global average temperatures. Building on this basis, one of the most important conclusions of the Working Group 2 report is that we're living in a world that's already altered by climate change. Warming of the planet is already having widespread consequences for people and for ecosystems around the world, from the equator to the poles, and also from the oceans to the mountains. It's also affecting both physical and biological systems and directly human systems as well. This is summarized in this map that you see on the screen that's produced in the Summary for Policymakers for Working Group 2. This really shows you the global picture of impacts in recent decades that can already be attributed to climate change. Each of the icons that you see indicates an impact identified for a specific area or across a broad region of the world, and our confidence in the link to climate change. One of the challenges in this kind of analysis is that, as you heard from Chris, climate change is not the only thing that's changing in the world. There's a lot of other factors that are affecting these systems. Even so, there are many examples where the effect of climate change can already be identified. And I realize that there's a lot of detail here. I think that the main point to take away is that impacts can be seen in all parts of the world. We can already identify changes in physical systems and in natural ecosystems. These have consequences for people and for society, and we can also see direct impacts in human systems as well. And I'd like to give you a few examples. One, a conclusion of the report is that glaciers are shrinking around the world, almost worldwide, due to climate change, and melting snow and ice are contributing to sea level rise and also affecting water resources downstream. And this figure shows estimates of changes in the amount of ice in glaciers in the Himalayas over recent decades, since the 1960s. And it shows both the average of local temperature or local measurements of mostly small accessible glaciers, that's the blue line that you can see, and then also the first Himalaya-wide satellite-based measurement, which is the gray range. And the key feature here is that you see a red zero line up at the top of the screen. All of these estimates are below zero, meaning that overall the glaciers in this area are shrinking over time. This is a map that shows areas of substantial heat and drought-induced tree mortality around the globe since 1970. And this has been attributed to climate change, this mortality in some regions, particularly in the western US and in Canada. But the overall picture here also indicates the vulnerability of these systems to climate extremes, which are also being affected by climate change over time. And as we'll talk more about in a minute, the impacts of extremes like heat waves and droughts tell us a lot about the vulnerability and exposure of current society, of current ecosystems, and they help us better understand the risks of climate change. Many species on land and in the oceans have already shifted their life cycles, have shifted where they live, how they migrate, how they interact with other species in response to ongoing climate change. And this gives you one example. It shows species movements across a wide range of ocean species and the distances these species are moving over time. What it shows is that species are moving towards cooler habitats in response to the ocean warming that's already occurred. And generally, this is movement towards the poles. The speeds are in kilometers per decade, and they range up to 400 kilometers per decade, which is extremely rapid movement. Shifting over to a human system directly, the climate change has also affected food production through negative impacts on crop yields. And what this figure shows is impacts of climate change on large-scale yields of wheat, soy, rice, and maize over recent decades and across both tropical and temperate regions. The y-axis you see here shows percent change in yields per decade, specifically due to climate change. And the ranges that you see indicate the spread across available data. And so for wheat and maize, which are on the ends of the figure, these are two of the world's most important food crops, and climate change has already had significant negative impacts on yields. And these have acted as an anchor that has held back the overall increases in yields that we've seen due to other factors like improving technology. So in other words, yields have increased less than they would have without climate change. For the effects on rice and soybean yields in the middle have been smaller, with a median change of 0 across all of the available data. Another key finding of the report is that people, societies, and ecosystems around the world are vulnerable and exposed to climate change in different ways. And much of that vulnerability and exposure is concentrated in the world's poorer populations. But there's also significant vulnerability and exposure in the developed world as well. What you see is that different characteristics in different societies contribute to these vulnerabilities and exposure. As I mentioned before, the impacts of climate extremes can tell us a lot about these factors, about vulnerability and exposure of current society, and they help us to better understand the risks of climate change. One way this manifests is that economic losses from climate extremes are generally higher in developed countries, while fatalities are concentrated in developing countries. If you look at one example comparing the events of two recent events, Hurricane Sandy here in the US and Typhoon Haiyan in the Philippines, economic losses were much higher for Hurricane Sandy. They're estimated to be over 65 billion, while for Haiyan, the losses were estimated at around 6 billion. in contrast, fatalities were much higher for Haiyan, nearly 6,000, while for Sandy, the fatalities were in the low hundreds. A key facet of our understanding of the differences in vulnerability and exposure around the world is that they arise from a variety of non-climate factors. And it's important to understand these underlying drivers to understand who is at risk from climate change and how. Risks are amplified for some populations due to inequalities that are embedded in current society, and these can be related to factors such as gender, age, or socioeconomic status. Another key finding of the report is that people, governments, and organizations around the world are already taking steps to tackle the risks of climate change and to respond to the impacts that we're already seeing. Adaptation is already occurring in many places around the world. One example pictured here is mangrove restoration and rehabilitation here in Tuvalu to reduce coastal flooding risks and protect shorelines from storm surge. Another example is flood protection in the Netherlands, which combines infrastructure like the Maasland barrier in Rotterdam that you can see here, with land use policies that prevent development in some areas so that the already inhabited areas are protected because flood waters have a place to go that's not where people are already living. And a key feature of the Netherlands approach is that they are thinking broadly about how best to transform current systems and change the aspects that are not working, given sea level rise and other coastal risks, rather than just making incremental changes. There's many more examples around the world that are documented in the report. Just to name a few, in North America, you can see that there's an emphasis on adapting energy and public infrastructure, again, to coastal risks and other risks due to climate change. In Central and South America, there's been an emphasis on ecosystem-based adaptation. In Europe, we've also already talked about coastal management. And in Africa, there's been a focus on disaster risk management. In Asia, an emphasis on development planning and other approaches. And in Australia and New Zealand, there's been a focus on planning for sea level rise and for reduced water availability. Another interesting example is that in the Arctic, where there are unique indigenous communities, there's been a focus on combining traditional and scientific knowledge to pursue solutions. And in the oceans, given the nature of ocean governance, there's been a focus on international cooperation and marine spatial planning as well. And I think some of the takeaways from this overall picture of the examples that we can see is that around the world, people are starting to incorporate climate change into their thinking, into their planning for the future. This is starting to translate into concrete actions that are aimed at making people more prepared for the impacts of climate change. And much of the Working Group 2 report is about what we are learning from these early steps and how we can use this learning to better prepare going forward. So at this point, I'm going to hand it over to Katie.